welcome back to my YouTube channel. Okay, so today we have an interesting video here to get this compressor up and running once and for all. So part one, previously on my channel, part one appeared of this project, which was the tumbling process to clean the inside of the vessel. Part two was the results and the protection of the face that I exposed to the atmosphere. So basically what I done with part one, during part one, I removed all the rust. So it was basically clean metal then by the video part two. And that's what I demonstrated, removing the rust. And then I demonstrated the prevention of rust in the future. So we're ready to rock. I have all the accessories laid out in the ground to the left of me. So this part three will involve getting the compressor up and running with the new motors, the two new pumps. Just to point out here, this is still a tandem compressor, but it's much bigger now. Well, it will be. So I'm actually looking forward to this, seeing it running. The pumps are two-stage Clark, BK114 pumps. So they're 25 CFM each. So they're massive for this little project. So okay, so what I'm going to do here now is I'm going to start. I'm not going to talk on too much here. I'm just going to start removing all this dirt that was left from the tumbling process. So that's just paraffin oil and the discolored paraffin oil from the media that I removed in part two. So I'm going to clean the vessel. Then I'm going to start by mounting the motors, the new pumps, and then I will have to go through a long process of plumbing the pumps to the vessel. So that's quite tricky because I don't have much room at the back of the vessel because of the large V-pulleys and the belt. So the belt sort of passes where the air is fed into the vessel. I don't want to turn the motors and the pumps round facing this way because I think it would ruin the look of the compressor. So what I'm going to do here now is start just cleaning this vessel down, as I say. Then I will demonstrate the accessories, the motors and the pumps on the ground before I mount them to the vessel. So here we go. I'll clean this now. So a lot of paraffin oil, you want this thing looking pretty. Pretty for the new pumps and new motors. So I'm only going to clean the top half here at the moment. And inside the channels too, of course. It's kind of awkward, you need to be double jointed in here. So this is only a quick wash. When the compressor's up and running, I will do a complete overhaul or a polish of this powder coated finish. So I'll continue on with this and then I'll demonstrate these pumps and motors and the accessories on the ground. Because it'll take a bit of time here cleaning in between these channels. Okay, so she is half cleaned. I have to do final preparations when the compressor's up and running. But for now, let's go into the accessories and the motors and the pumps. So I'll give a wee quick discussion about these. Then we'll move on to mounting the motors first. Okay, so everything you see here is new. So the two motors I sourced from a company in Northern Ireland. These two pumps are actually Italian. So I know I mentioned Clark pumps, but they're actually sold under the brand FINA. So FINA, I think that's how you pronounce it. So they're BK114 pumps, 25 CFM. These motors is 4 kilowatt. They run at 2800 RPM. So I selected these motors to suit these pumps. I will do a wee calculation here when I finish this discussion before I mount the motors to the vessel on why I selected 2800 and not 1400 RPM. Also, these two pulleys, these larger ones, came with the pumps. So these are, well, what do we see here? So as you can see, we have a taper and a keyway. The keyway is not used. So basically what you do here is you have a bolt and a washer, and they just basically sort of tighten on that taper lock. So these two pulleys are the ones that I have selected for this compressor. So these are selected for optimum performance from the pumps. So if I was to select pulleys too wee, the pumps wouldn't run at their peak performance, which is 25 CFM output. If they were too big, we would overwork the pumps. So also, that will follow in the calculations here as soon as I do this wee short discussion. So other accessories seen here on the floor, we have these two black pipes which basically run from the check valves to the switch. So basically what they do is they drain the air from the head of the compressor for the next time the compressor starts. So this little device here actually does two things. It's a pressure switch, but also it drains the lines before next startup. So I've decided to change this to this orange luminous color. So this is nylon tube to match that black. We have these new fittings for it. We have these new check valves that I discussed in part 1. I think it was part 1. Yes, it was. We have this automatic drain valve for draining the water out of the bottom of the vessel. So we can set that, what do we see, every 45 minutes. So I have it set at its maximum limit. So it blows off for, I think it's a half a second every 45 minutes. We have all these stainless steel bolts for the mounting of the motors and the pumps. We have these new belts. So I have selected this size for, obviously, what do we see? So when I line the motors and the pumps up together, I have selected that size for a specific reason. I'm not going to get into that right now, but I'll do it in a wee moment. So the belt type is SPZ 10mm wide to match the pulleys. Okay, so the next bit, and well, that's just a blow-off valve. That's a blow-off valve that was on the vessel. That's the outlet port and the valve. New gauge for the switch. I think I've discussed everything there now except this. So what you see here is, well, a 3/4 stainless steel union. These barrel nipples. So this is for the feed running from the pumps to the vessel. So there's a bit of work in that. I have to do a bit of bending these pipes here, galvanized pipe. So I'm going to start off this little video now by mounting these motors. So we'll do that now, and hopefully it all goes well. So I'll put the camera back in the stand here, and as I say, this will be the time consuming part here, plumbing the pumps to the vessel, because as I mentioned in the intro there, the belts, the pulleys are at the same side as the inlet ports here. So yeah, we'll do that now. We'll mount the motors and then we'll mount the pumps. So I should point out here, the pumps I need to drill new holes, and the motors I will be using these existing slots. So I'll put the camera on the stand and I will start this now. That was good. Okay, so I'm going to demonstrate here how I determined the size of the pulley for both motors so that both pumps were running at their optimum performance. So that optimum performance is 25 CFM. So we don't want to underwork the pumps, but we also don't want to overwork them. So the size of the motor pulley here is important. So let's say under normal working conditions, the motor equals the compressor. So I know that the motor's RPM is 2800, and I also know that the pump's working RPM is 1370. So let's put that down. 1370 RPM and the motor is 2800. I also know that the pulley size on the compressor is 400 mil. So let's multiply that by the RPM. What I don't know is the motor pulley diameter. So if I work this out now to get a number, that number will be 548,000. And if I carry the 2800 across, divide it here, that will give me the size of the pulley required for the motor. So the size of the motor pulley should be 195 millimeters or thereabouts. So obviously we don't get that size of a pulley. So if I select a 200 millimeter pulley, which equates to 8 inch, that is sufficient for the pump to run at optimum performances, or both pumps. Okay, so I have the 4 bolts, the 4 washers and 4 nuts for each motor ready. So these bolts that I'm using are flange head, so I don't require the washer at the top. So here we go. We'll go with motor for this side first. So these are quite heavy, so let me see. Wow, very heavy. Right, next one. Aye. Okay, so that's the bolts, the nuts and the washers on. They're not tightened yet because obviously when I go to tighten the belt, I'll be sliding the motor this way. So away from the pumps. So I'll mount the pumps here now. Well, we'll place the pumps on and we'll figure out where to drill the holes, the new holes. We also need to attach the 4 pulleys, so the 2 pump pulleys and the 2 motor pulleys. So pumps first. Aye. Pump 1 and pump 2. So we'll mount the pulleys here now. Okay, so what I'm going to do here now is turn the compressor around 180 degrees here to do the work on the pipes feeding the vessel. So it's much heavier now. It originally weighed 210 kilos. I'd say it's touching 300 kilos now, or a little bit more actually. So we'll put the pulleys on here now. The 4 pulleys. I'll bring the camera up nice and close. We'll get her into view here. There we go. So we'll mount the pulleys, we'll line the pumps to the motors, because the motors are more or less fixed now on this axis. So they can be slid this way, but they can't be brought in and out no more. They're sitting in the track. So we'll put the motor pulleys on first, then we'll put the pulleys on for the pumps, then we'll line them up using a belt that I have cut and all. So yeah, we'll do that now. Bring the camera up close. Okay, so I now have found the perfect position for the pumps within the platform. So that perfect position is the distance between the 2 holes. The center of that needs to be in center of the channel. So I've actually found one of the holes, well, one hole that I could use in the far end of the pump here. So I have the bolt in. What I need to do now is line up the 2 pulleys. So I mentioned there that I'm going to place the motor pulley on first. I'm not going to do that. I'm going to place the pumps pulleys on first because they can only be put on one way. Okay. I also stand corrected here. I found these keys in the bottom of the cardboard boxes that the pumps arrived in. So they're obviously required for the torque to drive the two-stage pumps. So we'll place these on here now, and then we'll move on to the motors pulleys. So that's the keys in the keyways. There's one pulley on. And there's the second one on. So these bolts now have Loctite on the end of the threads there. Big washers that come with the pumps. So I'll torque these to 20 Newton meters for the meantime. So everything's lagered in grease here to keep it from corroding. Well, until I get this project up and running, I want it to look half decent until then. There we go, 20 Newton meters. Oh, that's the wrong way. Okay, so the next step here is mounting these pulleys for the motors. So they can be put on two ways, this way or that way. So this boss part is not in the center of the V. So you know what I'll do, I'll put the camera up top here so you can see what I'm talking about. Okay, so there's the bolt that I'm talking about. So that bolt's only sitting there at the minute, but it's down through a hole. The bolt's M8 and the hole's maybe 8.5. So what I need to do now is drill, what do we see here? Drill 3 new holes for this pump and the other pump. But first things first, I want to make sure that the motor pulley lines up with the pump. So if I hold this motor pulley around there, sort of on the shaft, how does it look? Does the face of the pulley meet the end of the motor in the right place? So if I put this pulley this way, it also, if we look down on it there, it looks okay. It lines up with the V on the pump. Hopefully you can see that. But the shaft of the motor would protrude through the pulley, approximately around 10 mil or 15 mil. That would be okay. But I could also put that on like that. It would be easier to put on that way. And the shaft would sit flush with the end of the pulley at the side, the boss. So I'll make my mind up here, and then I'll batter it on with a mallet here. But I'm thinking about putting it on this way. It's just handier to get at this grub screw too also. So that's me looking down on it there now. You can see if I come to the end of the motor, about there, it lines up with the pump. So I'm definitely thinking about putting it on this way. So I'll put the camera back in the stand here, and then I'll make my mind up. Okay, so I also want to point out here, I have this pump sort of flushed this face the way I want it. At the back here we have it overhanging a wee bit. That doesn't matter because the foot of the pump's still on this channel. So I'm just going to go around the front here again. One final discussion here on this pulley. So if I put this pulley on this way, it means the entire shaft of the motor is covered. So no rust will start or form here at this point. If it did, the pulley would be hard to pull off. So say I put the pulley on this way would be the proper way. there'll be 15 mil of the shaft protruding through the pulley. So I'm going to go this way because the shaft is hidden completely, but also we have the grub screw at this side, and it doesn't really benefit me having it this way, even though it probably looks better, to be honest. But I think it's okay this way. So I'll put the camera on the stand here and then we'll follow on. Okay, so I'm going to tap these two pulleys on here now. A little bit of grease on both shafts. The key is in the keyway, set to 12 o'clock position. Lining the pulley up. And using this claw hammer and this nylon block. So I'm going to keep it flush for now. I'll tighten these grub screws later on when we get the pump right. So motor number 2, keyway lined up. So that's it flush. A little bit past, about a half a mil. As I say, we'll tighten these grub screws later. But first, I just want to demonstrate here looking down on both pulleys. So looking down on the motor pulley and the pump pulley, you can see how both these are lined up as good as they need to be for the moment. Okay, so the next step here now is drilling the 3 extra holes to mount the pump to this channel. So that's just 1 hole, 2 hole, 3 hole, and this one, there's already a hole there, as demonstrated earlier. So let's say if I fix this pump in position, once I square it up this way, I might need to adjust this pulley or this pump in and out, but we can't. The only adjustment we have that way now will be on this motor pulley. So hopefully that makes sense. This is fixed at this point. The pump is fixed here, and the only fine adjustment we'll have is here, which there's a lot, to be honest, because there's approximately maybe 25 mil to 35 mil in here, but all looking good. So we'll move on here now and we'll drill these 6 holes, 3 for both pumps. Then we'll move on to the pipes feeding the vessel from the pumps. So that's the pipes feeding these check valves. That will be done in stainless and galvanized pipe. So there has to be a wee bit of work here. I have to place a bend in 2 galvanized pipes, and I also have to cut new threads, 3/4 BSB. So we'll do that now, or sorry, we'll do the pump now, then we'll do that. So looking good. Okay, so my next step here now is drilling these holes. So I'm going to remove this pump number 1 first. So I'm planning to go outside here to make these pipes feeding the vessel coming from the head of the pump, or both pumps, but the rain's currently beating off the roof. So hopefully it eases off. So I'm going to start drilling these holes now. So these holes obviously need to match the base of the pump. So what do we see here? So this hole at this point is the hole of interest, the hole that I will be using. The other 3 holes need to be drilled. So the first hole needs to be 200 mil to this side of the platform. These 2 holes need to be running parallel to keep the pump square on the platform, to keep the pump perpendicular to this edge if we're looking at this face here. So the belt is running true to the motor. So I'm going to start marking these holes out now. First hole 200 mil this way. Then the second hole needs to be 169 mil to the back of the compressor. So this hole is important here for keeping the pump square. So these two holes then need to be parallel to this edge, seen here. And the fourth hole then needs to be 200 mil this way, running parallel to this edge, in order to get the pump square. So we'll mark this out now. So that's the first hole marked. Now on to this this third hole and then this fourth hole. So 169 mil this way now. Okay, so that's the 4 holes marked, ready for drilling. So we'll center punch these now and take it from there. Okay, so I went ahead here and removed the second pump. I have both platforms marked out. So we'll center punch these now and we will move on to drilling them. Okay, we'll drill these now. We'll start off with a pilot bit. Okay, so now ready for a bigger bit. I'm just going to slide these pieces of timber in so I don't hit the vessel. There we go. So a bit of timber done its job on there. Okay, so we'll mount these pumps again. Then we'll move on to the feed pipes. Well, the pipes feeding the vessel from the 2 pumps. Get rid of the swerve too, obviously. Okay, so first things first, I'm going to deburr these holes, bottom and top. Okay, now hoover the swerve. So when this is all finished, I'm going to remove everything again, polish everything with G-Theme cutting compound, then assemble everything for the final part of this video. Okay, so a bit of primer and a bit of activator mixed along with it to speed the process up here. So that's the edges now sealed, protected from moisture. There we go. All's good. Okay, so I am now ready to mount these pumps for, well, I say the final time, but I might remove everything at the end to give the vessel the final clean or polish. So the pulleys are mounted to the pumps as demonstrated earlier. They are now clean. There's no grease on them. So I only had grease on them to protect them until I got this project up and going. So okay, so the bolts used for the motors were these flanged head hexagon stainless steel bolts. I need 8 bolts for the pumps. They are coming in the post. So the bolts that I will be using for the pump are 45 mil long, so just 15 mil longer than these ones. For the meantime, I'm going to use these dome head screw bolts, 2 of them, either corner of the pump, just to mount it in its position so I can continue on with the pipes feeding the vessel. So we'll mount these pumps now. I believe these pumps is 32 kilograms, so they're quite heavy. So 1 in position. Whew. Okay, so 2 in position. Let's use these long screw bolts now. Just temporary. So that's 1 in. That's 2 in. Now on to the other side here. 3 in. out of breath lifting them. Okay, so that's 4 in. So there might be a wee bit of play in this. Now there's not too much. So I'm now going to discuss how I determined the length of the belt. So, okay, so we have this old SPZ belt, which is approximately, I think it's, what do we see, 2 meters long, or 2 meters in circumference. So, what I have done is I have cut this belt. I've moved the motor in to its, well, closest position to the pump, and I have placed the belt around the pulleys. And what I have done is I cut the belt to suit, then I measured it on the floor. So as you can see there at the minute, there's about, well, what do you see? There's about 20 mil in it. So I think I brought the pump in the final stages to suit the belt, because the belt was actually a bit too tight. So I think it was, what do we see? It measured 1650 flat on the floor, but when I got the belt then, the belt was actually too tight, so I had to bring the pump in to the hole, the first hole rather than the second hole that you've seen earlier. So let's try now placing this belt on. Okay, so that's a good fit. So remember here, I've got adjustment on the motor. So I've got approximately 40 mil. So that's it pulled tight. Obviously when I go to tighten the motor and the pumps, I will sort of have maybe a lever down here to tighten the belt, then tighten the bolts. So hopefully that makes sense. I'll bring the camera up close here in a wee moment, but for the meantime, let's put this other belt on. So this should be the same. Again, pulling this motor out to tension the belt. So there's about 20 mil left in the slots. So what I'll do is I'll bring the camera up close here. I still have to put the bolts, or nuts in the bottom of the bolts here. So I'll do that now. Just to keep it tight. We get this one on because it's kind of awkward. Okay, so I'll do that one later because it's tricky enough. So that'll keep it from lifting on me when I'm pulling this motor. So I'll bring the camera up here. Before we move on to the lines that will feed these check valves. So if we look here now at the slots, there's still about 20 mil from the center of the bolt to the end of the slot here. You see if I pull a wee bit tighter. As I say, I will need to, there's no adjustment here, there's no like bolt pushing the motor, so I'm going to have to lever this with a bit of timber against the pump or something. So, looking good. Let me go back a wee bit. All it needs now is the guards and these two pipes. So these two pipes, this is where the work begins. Then we have to mount all this accessories, or these accessories. So we'll do these pipes now. It's going to take a bit, but we will get there. Okay, so remember earlier on when I mentioned we might need to readjust these pulleys when the pump is mounted. So if you look at this, if I look straight down on it, you can see that the pulley of the motor needs to go in a bit, approximately maybe 3 mil. So we'll try that now just to see here. Okay, so if I square the motor up here, so when this flange is parallel to this face, or this edge, that's it square. So if I look down on this belt now, it looks better with the pulley and that little bit. So we'll do the same to this one. So if you look at this one, you can see how this pulley is sitting out towards me a little bit too much. So here we go. So it's not much. I think about maybe 2mm or 3mm, so it looks nice and straight there now. Maybe half a mil more. So there we go. So what I need to do here now is I need to run an air line or a pipe from the aftercooler here. You probably don't see it very well, but where my index finger is, I need to run a pipe down here behind the pulley and sort of a wee bend on it to pass the underneath of the belt to meet this check valve. So this will be done in 3/4 pipe so that the flow is not restricted from the pump to the vessel. So that's both pumps to the vessel. So I'll do that now. I'll bring the camera down nice and close and demonstrate what way I'm going to do this. So here we go. Okay, so I have tried to place the camera here in the best position. It's quite difficult to get everything into view because of the obstruction. So the pulley, the belt, this guard, I'm going to take that off, this cover even. So this is just to direct cool air onto the cast block and the head, cast cylinders. So we don't need that on to do this little task. So when I say little, that's quite tricky. So I already have this worked out in my head what I'm going to do here. There's limited space because of the belt, the pulley, this channel. It's just a bit of work on it here. So what I'm going to do here is I'm going to slack on these two M8 bolts at the head of the pump to remove the aftercooler. But first, I'm just going to demonstrate what I have in mind here first. So I have this 100mm barrel nipple, which is stainless steel. It's 3/4 BSP. Then we have this galvanized fitting, which is also 3/4 BSP. This is steel and this is stainless steel. So the idea is to screw this directly. What do we see? If I screw this into the fitting first, I can't screw this onto the aftercooler because of the bend. The bend will hit the actual pump itself. So the idea here is to take this off, then I'll explain what I'm doing. So this is just where I'm starting from. I'm starting at the head of the pump and working my way to the vessel. At the two sides, so this needs done twice. So this is a 3/4 female BSP thread, and this screws directly into it. So nothing will be sealed with PTFE or liquid for now. So I'll screw this back on. That's the bend screwed on tight. The barrel nipple screwed on tight to the aftercooler. And we will fix this back to the head of the pump here. So I have to continue on down here now to the vessel from that 45-degree bend. But it's a wee bit tricky. I'll just screw this on first. So obviously when I have the pipe screwed in to this bend and fed to this check valve, we don't want tension or stresses pushing up or pulling down on the pump, the head of the pump, as it more likely will break, crack. We want less stresses as possible. So I have to make this pipe now to sit in this position with the pump bolted, this fitting screwed in full. And yeah, so that's the reason I'm doing it like this. Hopefully that makes sense. So if you can imagine, if this line was say 10mm too long, the line I'm putting on here now to this 45-degree bend, it would cause a force on the pump pushing it that way. If it was too short, it would create stresses, and it would also more likely damage the weakest part of the pump, which would be this aftercooler. So it's important that I get this right on both pumps. Okay, so just a little sample here, a little example of the motor pulley turning the pump. Doesn't this suction? Okay, so on to the important step. So where do we start for this one? So as you know, I have the 45-degree bend sitting ready for the attachment of a BSP thread, a 3/4 BSP thread. So okay, so first things first, this check valve is designed for a copper pipe and a flare type seal to be pulled onto it. So that's why it's got this little bevel edge here, this little face. I'm not doing it that way, as you know. So I'm using 3/4 BSP fittings fed from the pump to the vessel. So I started off with stainless, then I'm moving into galvanized. Then we're going back to stainless, and then we're going to brass. So I've decided to use this stainless steel box union. So nothing's going to be sealed for the meantime. So the reason I've decided to use this box union is because, let's say I want to remove the pump in the future. Well, all I would need to do, well, I could remove these bolts, but I could remove this nut here on this box union. Let me give it a snap here. So this would come away with the pipe feeding the vessel. But for now, let's get these pipes made. So, oh, one other thing here. So I'll use the other one here. So these box unions are stainless steel, as I mentioned. They have a special seat that when you tighten this nut, everything is sealed up between this pipe and this pipe when attached. But they allow for a little bit of inaccuracy. So let's say when I bring my pipe from this 45-degree bend to the box union and they don't line up, this union allows for a little small minor inaccuracy between them. So let's say if I have a pipe screwed onto this 3/4 BSP and one at the side. These unions are kind of special wee components. So when you tighten it, alright, it goes tight. But let's say if I have these held, if I move these, there's a wee bit of movement in them here side to side. So I could tighten this a wee bit off the two pipes running straight to each other. Not much, but just the slightest wee bit. So these unions benefit this task. So that's the second reason. Okay, so we're going to move on here now. So I need a pipe now feeding from this 45-degree bend to this box union. So if I didn't have this union here, I would have to put on a straight joint. But then it makes everything completely difficult to work with. So I would need to screw the coupler, the straight fitting on first. Then I would have to screw the pipe into it with a bend on it. Then I would have to screw this 45-degree bend to the pipe and so on. So it makes everything awkward. So with this fitting screwed on to the check valve, as far as I can get it, I now can create a pipe from the bend to the fitting, to the box union. So what I have done here is I've created a test piece, well, two test pieces. So this is just a piece of pipe cut a little bit shorter than what's required. And I have also, when I stand up here, I have also cut this little piece. So that was about 2 inches long, and what I have done is I have threaded it, and I have also threaded the end of this pipe. So if I screw this test piece now into the union, 3/4 BSP pipe, and as far as I can get it, And then I screw this pipe into the 45-degree bend. I then can take a measurement between them. Oh, one thing first, I forgot to mention there. So if I get a straight edge, if I get this straight edge, take this part of the square off, and I get the verniers. So I have placed a small bend. What do I set this vernier to? 4mm. So 4.1 will be alright. So I have set the verniers to 4mm here just to demonstrate what I've done. So this pipe is roughly, I think it's 220mm long. So there's a gap here at where the straight edge meets the other end of the pipe of around 4mm. So that gives me an idea now on the pipe that's required for this pipe feeding the vessel, on the both sides, of course. This X, what do we see? This X marks the position where the bend was placed. So I'll screw this on now. So screwing it in as far as I can get it. We want the X looking at the camera. So we want the bend sort of down towards the vessel. So that's it. So when I go now to make my pipe for both sides, all I need to do here is add on 17mm. But I just make sure it's tight. Okay, 17mm or thereabouts. We have a little bit of wiggle room because of this union. So I'll bring the camera down close here, just to show exactly what I'm talking about. So again, both these pieces, this pipe and this pipe screwed into the box union, is test pieces. When I go to make my piece of pipe, I'll take a measurement from this, and the gap in the middle, add them together, and I have my length. I also have the position where the bend is required over that length. So 220mm to this point, there should be a 4mm gap between this part of the pipe and this part that's running off. So just to show here, if we look at this, we can see how well both pieces are lining up. If I didn't have the bend at this point, seen on here behind the pulley, this pipe would run off towards the vessel or towards this well that would run downhill, which would be useless. We don't want tension on the pump. So if I just hold this in position, if we look at it this way, keeping in mind that these here two pieces are cut square, the gap looks equal right around. So that's the pipe hitting this channel tight, and it's lining up perfect with the bend. I might screw a straight piece on here just to demonstrate that, or I might actually screw the piece in that I'm about to make. But one last thing here before we move on to the manufacturing of these pipes. The belt is tightened in its position, and there's about a ½ inch clearance between the belt and this pipe, so it's perfect. Again, it looks to be running off, but it's not. If I hold it in position there, it is spot on. So these test pieces are important. So outside now, hopefully the rain has stopped, and we will do these pipes. Okay, so the overall length of these two test pieces is 235mm. So if I add on 15mm or thereabouts, that should be more than sufficient. So Yeah, we'll go outside now. We'll cut these two pieces at 250 mm. Then we will start cutting the threads using the pipe threader and the 3/4 BSP dies. So here we go. So this piece of pipe was used for something, so I have to cut it clean here. I think it was used to roll stainless rings around it, like so. So we'll get rid of that. Okay, so it's always good to taper the edge of the pipe before you start cutting threads on it. Well, that's the way I do it anyway. So here we go. Perfect. Now you're ready to cut the threads. Okay, we're just going to mark where the bend is required. So 100 mm in from one edge. So we'll do this after we cut the threads. Now we're ready to cut the threads. Okay, so here we have the pipe threading kit. And here is the 3/4 die. So I have the pipe in the pipe clamp. And away we go. So a bit of cutting fluid on this first. So I'm going to keep going till the pipe protrudes out through the side of the cutter here. So the pipe threading tool is Presto brand. There might be a bit of traffic here on the road. A busy period now. So we're nearly there. Okay, so we're about 5 mil out past the cutter. We'll go a wee bit more yet. Couple of half turns even. Or one full turn. Whew. Okay, so we're 5 mil past the cutter there now. That will do. We'll back this off. Take a look at the thread quality. Oh, it looks beautiful. Okay, there you go. Want to see if the camera's focused there. Still looking good. I will do these other 3 sides now off the camera, 3 ends. So after that we will move on to the 2 bends. 1 bend on each pipe. Okay, so that's 1 done. Looking good. Okay, on to the second one. Second pipe. Really good colours. CT90. Unbelievable. Okay, so that's it. Perfect. tough. Nearly there. Okay, that's it. Two done. Looking good. Ready for the bends. At the black marks. Okay, so what you see on the floor here is the two pipes that I just completed. So we now need two bends 100mm on from this edge or this end. But first things first, I just want to sort of give a wee small demonstration on why this little 3-degree, what do we see here? If I can get this in view. On why this 3-degree angle is required. So what I'm going to do here is I'm going to take the camera off the stand and screw one of these little pipes onto the compressor itself. So when I move this camera stand out of the way here, so we'll go with either one of them. So screwing it onto the 45-degree bend here, screwing it on as far as it can go. Okay, so that's it. Nearly. Okay, so if we look here now where the two meal ends meet, we can see that they are out of alignment. So when I place this 3-degree bend 100mm in from this end of the pipe, these two meal ends will line up, and in turn we can place this box union in position. So what I'm going to do here now is I'm going to remove this one and take them outside and do the final wee task to these. All's good. Okay, so I have the pipe in the pipe bender. I have the mark on the pipe center with the die. So I will start pumping this ram now. Not too much, just enough, 3 degrees, so it's quite small. Okay, that'll be enough. So I've one done already. This is the second one. So hopefully this meets my expectations. So it's measuring 3.2, 3.1. So that's perfect. You have the other one here. It measures, let me see, 3.2. So I'll take these in now and try them. And then we'll start sealing everything up. All's good. Okay, so here we have the two pieces finished. I'm going to do a dry run here and just test this on the compressor. So screwing it into this 45-degree bend with this mark to the bottom. So the bend is in the right orientation. So here we go now. The two meal ends are lining up perfect. So we couldn't ask for better than that. So I'm now ready for this box union, the stainless steel union. So what I'm going to do here now is I'm going to start sealing everything up. Then I will move on to the electrics. So all's good. Okay, so just a wee example here on how well the two parts of the union are lining up. So the gap is nice and even right around the union. Okay, so the bolts, the nuts and the washers have arrived for the mounting of the pumps. So these bolts are 50mm long. I required 45mm long, but I couldn't source them in this type. So these are the hexagon flange type bolts. The nuts are nylock and the washers are standard type stainless steel washers. So I'm going to do that, and then I'm going to jump straight into the sealing of the accessories, the fittings, the pipes that I have made up here on the compressor. So there's a bit of work involved in this. I have a lot to do before I move on to the electrical side to do it right. So just want to touch on some of the items on the floor before I do this. So we have this blow-off valve, needs to go back on the bottom of the vessel. We have this new pressure switch. So this new pressure switch has to be connected directly to the vessel using this 3/8 barrel type fitting. But the problem is with this new pressure switch, it requires this reducer. So this is 2/4 inch. So I had to buy a packet here in order to get one. And me being me, I bought stainless steel. So these little plug type fittings is for the side of this pressure switch, seen here. What else do we need to do? So I just want to touch on the type of sealers that I'll be using for the threads, the different fittings such as this check valve, this union. So I'm very fussy, I don't want no air hissing at all. So I swear by this stuff, it's Loctite 55 pipe sealing cord. So I don't use PTFE tape at all. I always use this type of cord. I find it much better. It's much stronger than the PTFE tape that you get. I also use it in combination with this pipe sealer. So this is hydraulic sealers. I use the two of them together. I'll just give a wee example here. So all these fittings, well, first things first, this is a system that I have made up for my pneumatic air within my garage. So I never have to connect to my compressor at all. What I do is I feed the air from the vessel to this point using this ball valve here. And basically what happens is the air either goes in this way or it comes down this way, depending on where these T-port handles, the position they're in. So they always need to be 90 degrees from each other. So if that one's that way, this one needs to be the other way in order to get the air to go onto this line. So this is the main line. This is all, you could say it's automated. So I never have to drain the lines manually. It drains itself every 45 minutes. So I've made all this up, all these little pipes, these non-return valves, this little bank you see here, little manifold even. This regulator is also drained off using this solenoid, this valve. I have the solenoid and the timers in the house for both of these. They're exactly like this one. So these blow off every 45 minutes. So the idea here is to keep the water out of the line as best as possible, because obviously I don't have an air dryer. So I know I'm away on day one now, but I just think it's good to explain this system. So I think it's quite interesting. So the reason I have the air split between two lines is because this is breathing air for, it's a 3-stage filter for my helmets, my sandblasting helmet, or my other helmets that I use for spraying. So I think it's important to have a good setup here. So, well, not damaging my health. So this is breathing air. When this handle, this T-port valve is sitting this way, and this one is downhill, the air is coming in here through the 3-stage filter, down here and out this line. If I have this T-port valve this way and this way, it means the air is coming in here, high flow, down through this 3/4 inch regulator, this water trap, and back up and down this line. So that's for sandblasting or something. Say if I want high flow air, I would keep this handle in that position. This is 1/2 inch, so this 3-stage filter restricts the line to 1/2 inch at this point. This one is 3/4 inch the whole way down. What do we see? Down here and back up. So you can see, what do we see? I'm not wise. So the air, the pneumatic air, goes the whole way down the garage, seen there. So you can see the blue line. 3/4 inch the whole way down the garage, about, what do we see? 30 feet or 40 feet. So we have full flow air to another valve like this, a 3/4 inch ball valve. So the idea here of this drop is to get all the water to sit down at the bottom here. So you can see there that this pipe rises, 3/4 inch pipe rises the whole way up. I think it's about maybe 14 feet or 13 feet. So it's trying to trap the water at this point. So this is another one of these valves that blows off every 45 minutes. I think it's 45 minutes. What do we see? Yeah. So 45 minutes is the maximum time that you can get it blow off. So it blows off 45 minutes and it's set for, I think it's a 1/2 second, each one of them. So it's to keep the water as minimum as possible within the lines. So a blow off valve here, a blow off valve on the compressor, the vessel, and also another one blowing off the filters, the regulators. So that's it. I went under one there, I know, but we're going to jump straight into this now and start finishing all this off before moving into the electrical side of things. So I think I'm going to start with the easier little components first, such as these blow-off valves and this pressure switch. Then we'll move on to sealing this. This will be a much more awkward because I need to make sure that I get this bend in the proper position so it's facing down towards this check valve. So a lot of detail there, but yeah, we'll move on here now. So as I say, I swear by this stuff and I selected the best oil possible. If I didn't mention already, that oil is £60. I might have mentioned 3.78 litres. I only require 1.8. Each pump, I think it holds around 0.9 litres each pump. So we'll do that now, we'll move straight on to this, then we'll move on to the electrical side. Okay, so I went onto one there and I forgot to mention, each one of these joints seen here, so there's loads of them. So there's 3 joints at this T-port valve, there's 2 joints at this union, and there's 1, 2, 3, 4 unions. There's also loads of bends here, 1, 2, 3, and 4. And there's the ends of the filters and this regulator filter. So there's quite a few joints here. So these are sealed using this combination between the cord and the hydraulic sealers. And I have yet to have a leak yet. So I just wanted to point that out. So we also have this ball valve. So this here, I've mentioned this already, but this claw type fitting lets me draw air from the vessel at this point. So this is for sandblasting or something, using this high flow regulator. So let's say I wanted to use pneumatic tools from this point the whole way down the garage. I would use this flexi hose that is hung up to the roof. So at the minute, it's only hung up to finish this vessel on the ground, so I didn't want it getting in the way. It clips on to these special little brackets that I have made. The type of fitting is a Euro fitting. There's a swivel joint on it, so the hoses are top quality. There's one every 2 meters the whole way down the garage, and this blue line to the end of it actually measures 50 feet. I just measured it there with a tape measure, and that's only 50 feet from this point. So the pipe itself stores a lot of air. So I'm just going to go down to the end of the garage here and demonstrate the other high flow connection. Okay, so here I am standing at the opposite end of the garage. This is another high flow valve, high flow connection for sandblasting or something similar. So that blue line is 3/4 and it runs the whole way down the garage. 50 feet to this point from where the first red flexi attaches to it. So there's the first line, the flexi line from the far end of the garage. So there's 1, 2, 3 connections, and there's the 4th, and we have a rail too. So I have lots of connections there from the vessel. So we'll go back on here again. So this is number, what do we see? What did I count there? 1, 2, 3, 4. This is the 5th flexi. So there's a lot of connections here, just like to point that out. And there's a lot of fittings to the end of this blue line. And there's not one leak, and it's done about maybe 7 years. So I'm going to jump straight into this now. I waffled on too much there. I'm going to jump straight into the vessel here now and sealing all these connections. And then we'll move on to the electrical work. Okay, so I touched on everything and I forgot to mention where the water goes from the water traps. So we have this quadruple fitting. So each one of these valves that's controlled with the timer and the solenoid is fed to this fitting. Then it has another 12mm pipe fed out through the roof at this point and outside. So you can see it going through the insulation there in the roof. So that's a 12mm pipe, pneumatic pipe. Any water that's in these lines, the 3/4 lines, is fed out through the 12mm pipe, as is the water traps. So I forgot to mention that. And another thing I forgot to mention is, I only briefly touched on this oil. This oil is a 3X brand. I've done a lot of research in different oils before I selected this one. So it's a fully synthetic air compressor oil, non-detergent. It's ISO 100, which is equivalent to SAE 30. It's 1 US gallon, 3.78 litres. So it's quite expensive for 4 litres of oil at £60. I could have brought cheaper stuff, but I wanted to go with the best for my pumps. So I mentioned earlier there, the pumps, the capacity of the pumps is 0.9, so I only need 1.8 litres. So we're going to jump into this now and get this thing up and running. So we'll finish off the pneumatics, the sealing off all the threads, then we'll jump straight into the electrical work, then we'll pour this oil into the pumps. Okay, I had to call it quits there to this part of the project or video. The amount of work involved exceeded one video by a long stretch. Therefore, 2 more sections of part 3 will be created to get this beast up and running. These will come lightning fast as all the recording is completed already. I only realised I have around 4 hours of footage before I got to the final test stage, not including part 4. So stay with me, the project has exceeded my expectations. If you want to see this project evolve, please subscribe and hit the post notifications bell to see all the latest from my channel. Also, if you have enjoyed this video, please give it the thumbs up. Other interesting projects will follow very soon, such as my one-of-a-kind green e-bike beast, my unique mechanical iris, my aperture, and my unique smart glove. I mentioned before, you won't see these kind of projects anywhere else. The tremendous amount of time The effort, the dedication towards all these projects is something I've worked for since a very young age to achieve the things I do lonesome. Watch this space, it's only beginning to get more exciting. See you on the other side. Thank you and goodbye.